Okay. So starting with number 3, in an ANOVA hypothesis test, we reject the null when there is sufficient evidence to indicate that at least one mean is different from the others.
True.
Okay. What requirements need to be checked when performing an ANOVA hypothesis test?
The data has to be
normally
the variance.
distributed, and the variance, well,
Okay.
are equal for each group.
Yep. So number 5. To check if each group is normally distributed, do the following. Is that just the QQ plot?
Yep.
Okay. We assume the variance of each group is the same if the following happens.
The 4 times thing.
Yeah.
The largest variance is less than 4
Yeah.
times the smallest.
Okay. So, an ANOVA hypothesis test is equivalent to conducting 2 independent samples tests between every pair of samples. If there's a 3 sample, there are 3 pairs. How many pairs are there? Yeah, during 4 samples.
Wouldn't there be 6?
Because it just double.
Would there be 6 or would there be 5? Because you have 1 and 2, 1 and 3, 1 and 4, and then you have 2 and 3 and 2 and 4.
And then 3 and 4.
Oh yeah, there's another one. Okay, so yeah, 6.
Yep. 6. I agree.
Okay. Okay, using this data, what is the minimum variance for the 6 groups?
So I got that group C was the lowest that had 27.208.
Yep. And then what's the maximum?
The 50. 3.158, right?
Yeah, that's what I get.
Mine is not working. I literally.
Did you can you just not get it to open, or is it not calculating it right?
It's not calculating it right. It was just working when I was doing the prep work.
Did you do the analyze conversion thing? Or the, oh, what is it? You have to go transform automatic recode. Did you do that?
What are you talking about? I did not do that on any of the other things.
In the reading, it was talking about in order to use it, you have to do transform automatic recode, and that like puts your group letters into numbers or something like that.
Yeah, I thought it was supposed to do that. So how do you do that then?
Okay, so in your SPSS tab, hit transform,
Yep.
automatic recode, and then you do
The footwear.
yeah. Let's see. It was you have to type in whatever your groups are and then footwear, and then they just said put the word code after it. So in
So
you
you
put your
you put the footwear into the variable new name.
yeah, so you make sure it's your groups, not your measures. So different types of footwear, and then you put in the new name. They just did the
Code.
normal one and then put code after the name. And then just put OK.
That's not working.
What does it tell you?
The OK just doesn't light up. Oh.
Did you click add new name?
Yeah. And then it says variable name contains an illegal character.
What did you type?
I put footwear code.
Try just putting I don't know, try something else. Like random. Just put code, see what happens.
Okay, code worked.
And then you just use that group name for your groups instead of the other one.
Mm-hmm.
Okay. So are we on? Did you get the answers for 8 and 9, Monica?
No.
So you should get 27.208 for your minimum.
27208.
And you
And
should get
then
53.158 for your maximum.
okay.
Okay.
So you got it?
Yeah.
Okay, so number 10. The test of equal variance is satisfied for these data.
Is that where you just have to go? Or no, the
So
biggest
just
one has to be
divide.
larger than the 4 times the smaller one?
Yeah, so you just divide the whatever maximum answer we got and the minimum answer. And I think if it's less than 4, it should be good, and you should get like 1.7, something like that. So you should be good.
Yeah.
Construct a QQ plot for each of the 6 samples. Are they approximately Yeah, did you guys get it?
Working on it.
Okay.
So the kicking accuracy, it was normal. Is what I got.
Wait, what?
Is that what we're supposed to be looking at? What are we supposed to be looking at, actually?
The Q plot or QQ plot for each sample?
They're approximately normal.
Yeah.
So that's true.
Yep. Okay. So now perform an ANOVA test and observe the p-value is 0.081. Then remove the SOX data and perform the test again. What is the p-value when you remove the SOC data?
Okay. So the p-value is 0.018 or 81.
Yeah, originally, and then you just take some stuff away.
Okay. So we're gonna take away. How do you just take that away though? Just... I don't know how to take out the group.
Yeah, for Excel, you just kind of delete it.
Yeah, I was kind of thinking you might just delete it for it.
Oh, that's a good idea. I can do that.
Yeah, okay.
Okay, I got 0.309.
Yep.
Sweet.
Point. Uh-oh.
Wait, is it 0.309 or 0.039? Because I got 0.309.
I got 0.309.
Okay, just making sure.
And then 13. The test statistic for an ANOVA hypothesis test is an F statistic if the p-value, or is the p-value the area to the right or left? And it's to the right.
Yeah.
Okay. Now, using all this data, let's examine calories first, construct Q plots, and determine if just construct Q plots and compare the variance. See if they're normal or not.
So for sodium is definitely not normal. Well, okay, for poultry, it's kind of normal.
Well, we're doing sodium. Or no, not sodium. We're doing calories.
Okay, where are my calories? Calories. Calories of poultry is kind of normal. Because there's like a million of these. Because does it split them up into the, what's it say? Okay. For the 3 types of hot dogs, and determine. Okay. So
you just split up each one and then make a Q plot for that.
yeah, so the beef, poultry.
They are not normal.
Well, mine are kind of. I mean, they're not.
Like the ends are a little off, but for the most of it, it's a straight line.
Yeah, I'd go with pretty normal.
Beef is, but the other ones are less.
Mine are normal.
That's weird.
All 3 of them are. So that's straight.
Yeah. That's what I got when I put it. They're normal, and then the variants are equal.
So the assumptions have been met, and it's safe to assume each group comes from a normally distributed population.
Yeah, and we also assume that the variances are equal.
Okay.
Yeah.
Determine if run an ANOVA test to determine if the mean number of calories is the same for all 3 types of hot dogs. You should find that the degrees of freedom are 2 and 51, and the F equals 16.074, P equals 0.00 with a level of significance 0.5. What conclusion can you draw?
So it's less than, so you should have sufficient evidence to claim that at least one is different.
Yeah.
Okay. So we got, what number are we on now? 17?
16.
Oh, 16. Okay, construct Q plots and say what's wrong with them.
Of sodium.
So what I got was, what was it? Did I forget to change that one? No, yeah. So the assumptions have not been met. It is safe to assume each group, wait, no. Oh, it is not safe to assume each group comes out normally, but we assume that the variance is equal.
And why are we assuming that? Or why have they not been met?
Because the poultry one is not normal.
Yeah.
Because you see it's like one line and then like it shifts up a little bit and then there's another line. So if you were to do one line,
okay.
it wouldn't really work.
Okay, I gotcha.
And then if you also read number 17, it would also kind of tell you it was wrong.
Oh. Use To determine the mean sodium levels, what's the p-value for this test?
So how do you find the p-value?
It's the SIG, the SIG
What?
column.
But it's all
when
three of
you,
them?
yeah. I got 0.793, but I don't think that's right.
So the answer is for number 17, 0.179.
179.
Oh, I forgot to put the, oh no, that's, I understand why it's not coming up. Anyway, 18.
So based off that, what can we conclude? The p-value is bigger, so we have not enough information to reject. So we fail to reject.
So we do not have sufficient evidence to reject the claim. Yeah?
Yeah, that
Yeah.
all hot dogs are the same. So yeah.
Okay.
Okay.
Okay. You should get 100%.
Woohoo.
Okay. So do we have another group meeting Thursday, or
We do.
I was just
I think
to
it's
kind of go over?
Yeah, well, it's probably one of those big practice test things.
Yeah.
Again.
Okay.
But
Sounds good. And is this test due at the end of the week, or is it like?
it's due on Saturday night.
Okay.
So,
Sounds good.
Okay.
alrighty. See you Thursday.
See ya.
Sounds good. See you.